Hello everyone, welcome to MG Academy. The next topic in data structure is queue. Like stack, queue is important for storing data and queue is a linear data structure. Also, the elements in queue are stored in a sequential manner, like stack only. Okay, now for understanding queue, consider that you want to buy movie tickets or you want signature on a particular document. So for that reason, you have to enter a queue, isn't it? So earlier this was the scenario. Currently everything is done online, but previously you have to enter a queue and then according to your position in the queue you get the ticket or the signature on your document, isn't it? So similarly in data structure also the data is stored and retrieved in the form of queue. Okay, now the definition of queue. So queue is a linear list of elements, linear, in which deletion of an element takes place at one end called front. This front end is responsible for deletion and insertion of element takes place at another end called rear. So rear end is responsible for insertion. So there are two ends, one is front end and another is the rear end. So from front end the elements are deleted and from the rear end the elements are inserted into the queue. Okay, so whenever you think about the queue, think like this. This is the destination, suppose. Okay, and this is the queue, and the persons are standing in this queue. Suppose this is the movie ticket counter. You want movies, you want tickets from here. So the first person standing in the queue will get the ticket first and will leave the queue first. So this person will get the ticket first and will leave the queue first. So from here, this person will be removed from the queue. Okay, so this end will be front end because from this end, the person will be removed from the queue, isn't it? And from this end, new person can enter into the queue. Okay, so this end will be the rear end. Understood? Two ends, rear end and front end. Okay, in some books or videos, you will see that the front end is here and the rear end is here. So don't get confused. Just mention the correct direction and just remember that rear means insertion and front means deletion. Okay. Now, queue is also called as first in, first out, FIFO. What is the meaning of FIFO? The first element in a queue will be the first one to be removed from queue. See, this is the first element in the queue, the first person standing in this queue, right? So this first person will get the ticket first and will leave the queue first. So this is first in, first out. Okay, so stack follows the principle of LIFO, last in, first out. And queue follows the principle of FIFO, first in, first out. Okay. Now the best example for queue is standing in a line for ticket reservation. And this is the simple representation of queue. So this is the simple representation. In this is the front end and this is the rear end. From this end there will be insertion of elements. Okay. And from this end there will be deletion. Deletion. Okay, so this is a simple representation. This is the indexing. This is a queue. Now let us understand the basic operations of queue, and they are insertion, deletion and display. So these are the three basic operations of queue. So what is the meaning of insertion? Insertion means inserting an element into the queue, and the terminology which is used for insertion in queue is enqueue. So enqueue is entering or inserting elements into the queue using rear end. Using rear, enqueue operation will be performed, and the another operation is the deletion. So deletion means deleting an element from the queue, and the terminology which is used in queue for deletion is dequeue. So dequeue means deleting elements from queue using front and dequeue operation will be performed. And display is just displaying whatever elements are there into the queue. Okay, these are the operations. Now there are two conditions, and those are overflow and underflow. Overflow, what is the definition of overflow? Insertion into queue which is full. A queue which is already full and you are trying to insert more elements into it. At that time it will report overflow condition, that the queue is already full. How can more elements be inserted? Okay, and for doing NQ operation we have to check the overflow condition. Which operation? For performing NQ operation we have to check the overflow condition. Okay, and what is underflow? Deletion from empty queue. So from an empty queue you want to delete more elements. So this is not possible. At that time it will report underflow, and from dequeue operation we have to check underflow condition. Which operation? Dequeue. Okay. Now let us understand the implementation of queue using array. So we are using array. So this is a static allocation, and for that we have to mention the size before only. So let us take size as 10. Okay. Size equals to 10, which means maximum 10 elements can be stored into the queue. Okay. Now there are two ends, front end and the rear end. So we will initialize them as front equals to rear is equal to -1. Okay. So we know NQ operation, that is insertion, it is performed through the rear end. So for insertion, that is NQ operation, we have to update the rear end, and for dequeue operation we have to update the front end. Okay. Now let us consider a queue like this. So this is a queue. Okay. And now front is at -1 and rear is also -1. Okay. Array, queue array. Okay. Now the first operation is the NQ operation. For performing NQ operation, first we have to check the overflow condition. Overflow condition means queue is full. We have to check whether the queue is full. And if the queue is full, we cannot perform the NQ operation. For this, the condition is if rear is equal to size -1. If rear is equal to size -1, then queue is full. And in that condition, no NQ operation can take place. So if this condition is true, then print as queue is full. Okay. And if this condition is not true, then it will enter else part. In the else part, we will scan the element which we want to insert into the queue. So scanf %d. Okay. So in this line, we will read that element which we want to insert into the queue. Okay. If front is equal to -1. If front is at -1, then we have to assign front as 0, because we know that front point to the first element into the queue, isn't it? So we will increment front as 0. So write front equals to 0. Okay. And for inserting element, as I told you that for inserting element, that is for performing NQ operation, we have to update the rear. Okay. So we have to update rear. So rear plus. See, rear is at -1. Now we have to insert element at the 0th position. For that reason we have to update rear. So rear will be equal to 0 and the element will be inserted here. Okay. And last, wherever the rear is pointing at that position, the element will be inserted. So q of rear equals to element. If rear is pointing to 0, then q of 0 equals to element. If rear is pointing to 1, then q of 1 equals to element. Okay. So this is a simple NQ operation. Now let us understand it with the help of an example. So first of all, check this condition, which is the most important condition, that rear equals to size minus 1. Now the value of rear is minus 1, right? Value of rear is minus 1. Size is 10. So 10 minus 1 is 9. So minus 1 equals to 9. No. Condition not satisfied. So it will not print q is full. It will enter into the else part, and here we can scan the element. For example, if we want to insert 10 into this q, so we will scan here 10. So we will read this element 10. Now front is at minus 1. So we will increment front as 0. Now front will be pointing here at this position. Front will be at 0. And now rear plus plus. Rear is minus 1, isn't it? So rear plus what? Rear will be pointing to 0. So rear will be pointing to 0. And q of 0. Rear is 0. So q of 0 equals to element. Q of 0 equals to element. Element is 10. So 10 will be inserted into the q. Okay. So here 10 will be inserted. Now the next iteration. Now the value of rear is 0, isn't it? So 0 equals to 9. No. Condition not satisfied. So again we will enter else part. Now we have to enter 20 into this q. So we'll read 20. Front is at 0. Rear plus plus. Rear is at 0. Now it will point to 1. So q of 1. Rear is 1. So q of 1 equals to element. Q of 1 equals to element. And element is 20. Okay. So 20 will be inserted here. Again we'll check for the next element. That is. So now rear is at 1. So 1 equals to 9. No. 1 equals to 9. No. Condition not satisfied. So else scan another element, that is 30. Suppose we want to insert 30. So now 30. Again, if front equals to minus 1. No. Front is at 0. Okay. Then rear plus plus. Again rear will be incremented. Now the value of rear will be 2. So q of 2 equals to element. Q of 2 equals to element. Element is 30. Now 30 will be inserted in the second position. Q of 2. Now 30 is inserted. Now again we will see for the next iteration. Now the value of rear is 2. So 2 equals to 9. No. Condition not satisfied. So again we will enter into the else part. Again we will read another element, that is 40. Again rear will be incremented 3 and q of 3 equals to element. Q of 3 equals to element. So element is 40, right? So 40 will be inserted here. So slowly rear is also incrementing now. First it was at 1, then 2, then 3, and finally now it is here on third position, isn't it? The front is here and rear is here. Okay. And this will continue unless and until the value of rear becomes 9. So when value of rear will become 9, so 9 equals to 9. Yes, condition satisfied. At that time it will print what? Q is full. Okay. So this is the simple NQ operation, that is inserting an element into the Q. Okay. Now the next operation is the DQ operation. DQ means deleting elements from the queue. Okay. So for performing DQ operation, we have to check Q under flow condition. That is, we have to see whether the Q is empty. And if Q is empty, we cannot perform the DQ operation. Okay. So if rear is equal to minus 1. If rear is equal to minus 1, then Q is empty. Because we have seen the initial condition is rear equals to minus 1. When there is nothing into the Q, at that time rear is equal to minus 1. So if this condition is true, print Q is empty or under flow. Okay. After this, if this condition is not true, then it will enter into the else part. So in the else part, we will delete that element to which the front is pointing. Okay. So element is equal to Q of front. For instance, now front is pointing to 10. So 10 will be deleted from the Q. Okay. So we just print as printf person D is deleted. What is deleted? Element. Okay. And then after deletion, front will be incremented. So front plus plus. Okay. So this is a simple DQ operation. Now we will understand it with the help of an example. So first we will check the condition if rear equals to minus 1. Now rear is pointing to 3, isn't it? So 3 is equal to minus 1. 3 equals to minus 1. No. Condition not satisfied. So now it will enter the else part. In else part, element equals to Q of front. The front is pointing to 0 and at 0th position, element 10 is present. So Q of 0 is 10. So 10 will be assigned to element and the element will be deleted. Okay. Element equals to Q of 0. And at 0th position, 10 is present. So 10 will be removed from the Q. So after removing 10, front will be incremented. Now front will point to one location. Now 10 is deleted. Now front is pointing to this location. Okay. Again we will check the condition. Rear equals to minus 1. Rear is constant. Rear is 3. So 3 equals to minus 1. No. Condition not satisfied. Again it will enter into the else part. Element equals to Q of front. Now the value of front is 1 and at 1 position 20 is present. So element equals to Q of 1. At this position 20 is present. So 20 will be deleted from the Q. After deletion, front will be incremented. Now value of front will be 2. So now front will be pointing here. Okay. So again we'll check the condition. Rear is constant. So 3 equals to minus 1. No. Condition not satisfied. Again it will enter into the else part. Element equals to Q of front. Front is at this position. So Q of 2. Element equals to Q of 2. And at this position 30 is present. So 30 will be deleted from the Q. Okay. And after deletion again front will be incremented. Now front plus plus. And now front will be pointing here. At the third location. Okay. Now again we'll check. Rear is constant. So rear equals to minus 1. No. Condition not satisfied. So it will again enter into the else part. Element equals to Q of front. Front is at 3. Element equals to Q of 3. And at this position 40 is present. So 40 will be deleted from the Q. And after deletion again front will be incremented. Now front will point at this position. Okay. Again we'll check this condition. Rear equals to minus 1. Rear is 3. 3 equals to minus 1. No. Condition not satisfied. Now though this condition is not satisfied, but still Q is empty. You can see all the elements are deleted. Isn't it? The queue is empty. So there is another condition, and that condition is or front is greater than rear. So if this condition is true, then also queue is empty. Now front is at 4 and rear is at 3, isn't it? So 4 is greater than 3. Yes, that is front is greater than rear. Yes. So if this condition is true, then also queue is empty. So there are two conditions for queue is empty. And if any of this condition, either this or this, if any one of this condition is true, then also it will print as queue is empty and no further deletion can take place. So this was a simple dequeue operation. Okay. So finally, the next operation is the display operation, and for performing display operation, we have to check the queue empty condition, and if that condition is true, then we cannot perform the display operation. Okay. So if rear is equal to -1 or front is greater than rear. So these are the two conditions, and if any one of this condition is true, then we cannot perform the display operation. So in case if any of this condition is true, then just print printf is empty. Okay. And if this condition is not true, then it will enter into the else part. Else, that is a simple for loop for I equals to front, I is less than equals to rear, I plus plus. Okay. And then it will print the element q of I. So this is a simple display operation. Let us understand it with the help of an example. So first we will check the queue empty condition. Rear equals to -1. No, rear is at 3. Okay. And front greater than rear. No, front is 0 and rear is at 3, which means front is less than rear. Okay. So we will enter else part for loop I equals to front. Now I equals to front. Front is at 0. So 0 will be assigned to I. So I will be equal to 0. Okay. And I is less than equals to rear. I is 0. 0 is less than equal to rear. Rear is 3. Yes. Condition satisfied. So it will print Q of I. So Q of 0 is 10. Q of 0, which is 10. Okay. Now now I plus plus. So value of I will be 1. So I equals to 1. 1 is less than equals to 3. Yes. Condition satisfied. So Q of 1 will be printed. At 1 position 20 is present. So Q of 1 equals to 20. So 20 will be displayed. Now again I will be incremented. I will be equal to 2. So 2 is less than equals to 3. Yes, condition satisfied. So Q of 2 equals to 30. So 30 will be displayed. Now again I will be incremented. So value of I will be 3. I equals to 3. Yes. 3 is less than equals to 3. Yes, condition satisfied. So Q of 3 will be printed, and that is 40. So 40 will be printed. Now again I will be incremented. So value of I will be 4. I equals to 4. 4 is less than equals to 3. No, condition is not satisfied. So it will come out of the loop and display will be stopped. Display operation will be stopped. Okay. So This was a simple display operation. Hope you understood my today's lecture, and if so, then give this video a big thumbs up, subscribe to my channel and share it with your friends.